In Chapter 8, Section 4, we're looking at the confidence intervals and sample size for proportions. So when we're talking about proportions, we're talking about the idea of 6% of Colebrook Academy students are taking statistics this year. Our 6% is what our proportion is. So we have 6 out of every 100 students are taking statistics this year. And I figured this out by saying that we have 7 students who are taking statistics. And we have about 110 kids at Colebrook Academy. I divided this out and it ended up being about 0.06. So I know that I have 6%, which is also going to be represented as a probability or as a fraction. The symbols that we'll be using to talk about proportions, we have lowercase p, which stands for our population proportion. And then we have p hat, which stands for our sample proportion. To find p hat, we have the equation p hat equals x over n, where x stands for the number of sample units in favor of what we're looking for. So in the case of Colebrook Academy students taking statistics, 7 was my x. And then n, just like before, stands for our sample size. So our sample size was Colebrook Academy. Colebrook Academy has about 110 kids, I believe, at it. So we had 7 over 110, and we came up with our p hat from that. Now, besides p hat, we also have q hat. And q hat is going to be the complement of p hat. So q hat is equal to 1 subtract p hat. We can also look at it as n subtract the number in favor over n. Both of these are going to show you that it's the complement of p hat is q hat. Let's calculate the proportions p hat and q hat for the number of students taking stats at Colebrook Academy being p hat. So we have p hat equals our 7 over 110. We divide that in the calculator and we get 0.063, which is about 6%. And then we look at q hat, and we have 2 different ways we can calculate q hat. First, let's look at the number of, we'll do the long one first. We'll take the sample size, which was 110, and we say 110. Let's write what I actually say. We'll take 110, and we're going to subtract 110, subtract the 7, and we get 103 over 110. When we calculate this out, it comes to be about 0.936, which is about 94%. We could also calculate q hat by saying 1 subtract p hat. So we have 1 subtract our 6%, 0.06, which gives us our 94%. 0.94, which is equal to 94%. We can also calculate our confidence intervals for these proportions. So the formula for the confidence interval of a proportion is going to be p hat subtract z sub alpha over 2. We're back to our z values, or z scores here, not the t values. That's going to be times the square root of p hat times q hat all over our sample size. And that, again, is going to be p, our population proportion, is going to be between this and the positive version of this. So we have p hat plus z sub alpha over 2 times the square root of p hat, q hat, running out of space here, over n sample size. Remember that p hat is our proportion of the sample that is in favor of what we're looking for, and q hat is not in favor or the complement of our p hat. And yes, they're called p and q hats. It's also be said that our sample size, pencil's not working, hold on. It's also be said that the sample size times our population proportion and our sample size times our complement to the population proportion must each be greater than or equal to 5. And also, when we're calculating our confidence intervals for proportions, we're going to round to 3 decimal places. So an example of finding the confidence interval for a proportion, we have a sample of 500 nursing applicants, including 60 from men. We're going to find the 90% confidence interval of the true proportion. When we say true proportion, we're looking at, get back to my pen, we're looking at what is the population proportion. So true proportion, same thing as population proportion. So the first thing we got to look at is, what is p hat going to be equal to? Well, p hat's going to equal our 60 over 500, which comes out to be 0.12. We also need to know what is our z-score of alpha over z of alpha sub alpha over 2, and we're looking at 90% confidence interval, so we know it's going to be 1.65. You could also look this up or use your calculator to calculate it. And what else do we need to know? We need to know what q hat equals. So if p hat equals 0.12, we know that q hat is going to be the complement of that. So 1 subtract 0.12 gives us 0.88. We also need to know what was our sample size. Our sample size was 500. So using this information, we can substitute it into the equation. We have p hat, which is 0.12, subtract our z sub alpha over 2, which is 1.65, times the square root of p hat times q hat, so 0.12 times 0.88 all over the sample size of 500. And that is going to be less than what our true proportion, or our population proportion, is going to be. And then we have, again, 0.12. Only thing changing now is we have a plus sign. 1.65 square root of 0.12 times 0.88 over 500. Now let's calculate what this is. On the left side, we get 0.09. Sorry, the calculator went by. So 96. And that's our 3 decimal places. And on the right side, we get, and on the left side, we're going to get 0.144. So we have p here, 0.144 on this side. So we're looking at it, and we have 9.6% p and 4.4%. So we know that our true proportion, our population proportion, is going to be between 9.6% and 14.4%, with a 90% confidence in saying that. Just like we do with our confidence intervals of a normal distribution, we also can find the sample size for the interval estimate of a population proportion. So to find our sample size, we know that n is equal to sample size, so n is going to be equal to our p hat times our q hat times z sub alpha over 2 divided by e, which was our error estimate, and we're going to square that. If we know what our p hat is equal to, we're going to be using that, but if we don't know what our p hat is equal to, we're going to assume that p hat equals 0.5, and this will assure us that our maximum range is going to be given, because p hat times q hat is going to give us the biggest possible number for right here. Let's look at one of these problems. A researcher wishes to estimate with 95% confidence the proportion of people who own a home computer. A previous study shows that 40% of those interviewed had a home computer. The research wishes to be accurate within 2% of the true proportion. Find the minimum sample size necessary. So we use our formula, and we find that we have n. Oh, I'm going to get my pen. We want to find n, is what we don't know. We know that p hat is going to be equal to 0.4 from our 40% of people who own it. Our q hat is going to be equal to 0.6 because it's the complement. We also know that e is going to be equal to 0.02 from the 2% here. And then we need to look at what is z sub alpha over 2 for 95%. Z sub alpha over 2 for 95% is 1.96. So we substitute these into the formula. We say n equals our p hat times q hat, so 0.4 times 0.6 times our z sub alpha over 2, 1.96, over our e, which is 0.02, and we square it. We put this into a calculator and we find out that we get 2,304.96, which we round up to be 2,305 people. So the number sample size he needs to get is 2,305 people, so that he can accurately estimate how many people are going to own a home computer when we look at the population proportion. So what do we do if we don't know what our sample proportion is going to be? So we look at this and it says a researcher wishes to estimate with 90% confidence the proportion of people who own a car phone. The researcher wishes to be accurate within 5% of the true proportion. Find the minimum sample size necessary. So once again, we're looking for n. We don't know what n is. We do know that we have a z sub alpha over 2, which is 90% confident, which is 1.65. We also know that we need our estimate to be within 5%, so we have 0.05. But we don't know what p hat equals. We don't know what q hat equals. So both p hat and q hat are going to equal 0.5. Now that we have this here, p hat, q hat equal 0.5, we substitute into our equation. And we get n equals 0.5 times 0.5 times 1.65 over 0.05 in parentheses squared, and that equals 272.25. So we round up, so you need 273 people to ask. That's what our sample size is. So that concludes this section. Go do your questions.